Hello world, and welcome to part 3 of the chemical property import series. We have created proper regular expressions and imported the data in a rough format, and now it's time to actually put it in a dictionary so that everything can be used. So if we just do something as simple as single props equals single props pattern dot find all text dot text and run that. That should interpret the regular expression that we got before. And so now, if you just put in single props and run, would you look at that? It's all the information that we'd ever want in a fun little list. But we don't want it like this, we want it in a dictionary. So, simple thing here, single props equals dict for dictionary of single props. Easy enough. Pop it in, run. Oh yeah, gotta do single props again, and boom, we have a dictionary for all of these values. Easy enough. Now we're gonna go through the process of a few things. Part 1 is that critical pressure, critical temperature, all these things, most of the time people use things like CP or CT, abbreviations for those things. And so we're going to implement that. But then also, you notice that before we also have coefficients here. And so that'll refer to things that have multiple values. Vapor pressure coefficients would be our specific values for chemical or whatever, in which you need multiple numbers all at once. And so we're going to have something that goes through and gets all of those. So it can be like PVAP A, PVAP B for vapor pressure, or the first coefficient, vapor pressure of the second. And we're going to have to do this for all of the things in here. So, for step 1, this would take absolutely forever to type in. So I'm going to copy and paste real quick and explain it. Bit. So extract single props, extract coefficient props. Simply, we have dictionary of molecular weight is MW, critical temperature, TC. Similar thing with the coefficients. Run that. Okay. Now, to get to the more complicated part of coding this out. So first, let's create just an empty dictionary for props. And then for these variables that we're going to use called KV or key and value in extract single props. So going through that dictionary that we defined from before, dot items, telling it to actually go in there. Props of value equals single props of key. So it's going to go through each of these and get what we need. And then to improve upon this, we're going to do something called a dot map. And a dot map essentially improves on a dictionary. So you can just do like water.pvap_a or something like that, or for the class involved and things. But dot map is its own thing, and so we're going to need to import it. So from dot map, import dot map. And then also, since it's something special, you have to do this install part, which takes a hot second. And then run that. Cool. Just for save everything. Shift enter through, except here, because we're still working on it. And then to keep going, we're going to create another key, which, as I said before, is just a list that's easily appendable. And then for all of these things in there, I'm going to create this variable called coefficient name strings equals a dictionary of coefficients name pattern. There we go. Nope. And we're going to go within there, find all text.text, the same thing we did above here. We used to get all the single props. Alright. What is this? Seems to be typo. Find all. That should run. Okay. So if I do props dot molecular weight, shift enter, gives me a number. Look at that. Isn't that cool? That's the power of the dot map. Alright. And with the dot map, you can have that little interface that I just used, where you can see the different things that you have access to. So, now, moving on a little bit, I'm going to create a different loop that is somewhat similar for the coefficients. So for key and variable, and extract coefficient props dot items going in it. Again, very similar. Props of v equals coefficient name strings this time of k, and then define coefficient values as another key. And then I'll explain this in a second. Create another variable called temp, coefficient name strings of k, and then a bunch of fun stuff that we have to do just because of the problems with the data we're given. We have to do this part because otherwise we'd get a bunch of spaces in our data. So first we're telling it that, and then we're saying for the coefficient, for some variable coefficients in that, what we're calling temp, if the thing we're looking at is not equal something, the space, then we're going to actually record it in coefficient, and the coefficient values thing that we made up here, that blank to key for. So coefficient values dot append, and then we have to convert it to a float as well, because otherwise it would be a string, I believe. And then one last loop that just pulls it all together. So we're going to, because a lot of this has to do with strings, we're going to have to do some string manipulation. And so to do that, we're going to have to import string. Oh, gotta make sure to run it before I accidentally get an error. Boom, boom. And then the fun part of for some letter. So it's going to go through. So what this is going to do is for the things that have coefficients of multiple values, such as like, you know, like I said before, the coefficients for PVAP, there's like multiple of them, so it can be PVAP A, B, C, D, E. And so what this is going to do, it's going to go through that and name that accordingly. And it's going to look a little complicated, but this can, and then telling it, name it all uppercase, so it's going to be PVAP capital A, and then as a string, right, and then the next part within that, within the same dictionary or whatever, will be the value of coefficient, that coefficient's value, so aptly named coef values. Cool beans. And then, just real quick, props v plus letter, just the syntax, equals value. Alright, hopefully no error, and invalid syntax. How'd I know? Okay. Let me, oh, you know what, anytime it's invalid syntax, usually it's the colon. Cool, it works. And so that probably seemed convoluted. I went a while without demonstrating, but now if we do props and just enter, see what it looks like. This is what I've been referring to this whole time. So you can see that molecular weight will give you 46.096, or you know, I'll do it right now since it's a dot map. Dot, and then wow, look at this. I can do the specific coefficient of vapor pressure. whoop-de-doo, it's that. And now that we have all this, we're going to dive in next time into actually using them in some useful manner. I'll show you what we can do with all this.